No. We're not graphing these. Oh, yeah, I thought I was going to say graphing triangle, and I was actually graphing so confused.
This is more than just the parent. This, I would venture to say, is probably one of the harder things that we have done thus far. So,
I thought everything was hard.
no, it won't be because you're paying attention. I'm trying to get them attention. All right.
It was exploded.
As a reminder, this could be sine or cosine.
Why can't it be?
And tell me what A tells us.
Yeah. Absolute value of A is an amplitude.
That's your amplitude. What is amplitude?
How high and low it goes.
That's right. So if I'm not centered right at the x-axis, then then, no, that's mine. You cannot have the Kit Kat.
I mean, you just said that.
Davis gifted me that. That was very kind. Okay, so amplitude max minus min divided by 2 if you're not centered at 0, yes? The height. All right. What's B? It does impact your period. How does it impact the period? Close.
What are these?
2 pi over b is your period. What is a period?
How long it takes to complete one cycle?
There you go. A complete cycle. Okay, so we're going to use these things. Amplitude. Thank you for that. Parent function. I'm reviewing a little bit before we jump. All right. Parent function. Logan, do not throw anything else in my room. All right. Be done with it. Just be done with it. We're done. Okay. Because they keep getting thrown at me. Focus.
I need to go change my student survey.
Oh my gosh! Focus. I know y'all can't focus because I can't focus. I can't even get my thought. Okay. Parent graph, sine and cosine, right? What is the period of just the parent? Okay, 2 pi, that's right. Sine and cosine parent graph, okay. What is the period of the tangent? Pi, 1 pi, right? It gets everything done in 1 pi as opposed to 2 pi. What's the amplitude on tangent? Yeah, are you cheating?
We have the paper right.
Okay.
We have the notes right in front of us.
Okay, that's okay. Not cheating. It's not cheating. I just thought, yeah.
It's false accusation.
It is. Thank you.
Good job, Miguel.
All right, so let's look at how we're going to do this.
You 18, whatever that means.
Let's just start easy. It does have a stretch of 2. Now, let's think about, I have to put the parent on there so I kind of see the difference. If I graph just the parent here of sine, what does that look like? Not this one, but if the parent. What does the parent look like? What's this? Where do I start, though? That's always the hardest part, is where to start. The sine of 0 is 0, right? So it's 0, and then it goes up to 1, back to 0, down to -1, back up to 0, and that's my pattern, right? So, and, yeah. Where's my dot?
So we're supposed to just remember the stretch.
Yeah, but I'm going to show you how to do it with the amplitude and the period. Okay, if that is my parent graph, right, how does my blue graph here compare to the parent? Everything's the same except what? Not this way. Up. Because what's changed here? Amplitude. What is the amplitude here? Okay, so that means I haven't shifted up or down any. The only thing I've done is I've taken my highs and my lows and I'm moving them to 2 instead of to 1. Okay? It's not impacting my period. My period is still 2 pi. So, it's just going to go here, here. Because if you find your period, right, it's still 2 pi over b. B is 1, so your period's still 2 pi. So the only thing I have to adjust, that's right, my zeros are still the same. So this is what that graph looks like. Whoa. I didn't mean to do that. How much what? When you're talking about your amplitude, you just go to the highs and the lows and you stretch them out because you want the distance between the highest and the lowest to be double the amplitude. So the distance between the two would need to be 4, right? 1, 2, 3, 4. But yes, if you're centered at 0, you just go to the number it tells you and you're good. Okay, and that's how we'll do them. We'll shift them after we stretch them to make it a little easier. All right, so that was an easy one. You ready for a little bit harder one? Okay, tell me when you're ready. Thanks, David. All right, let's see what's happening here. Oh, yeah. I know. You were doing good then. You're still doing good. You're still doing good.
So how do you?
Just moving the highs and the lows. All right, ready? Because before, when it's 1, the highest point was 1, the lowest point was -1. But now I'm taking it to 2. Not so much dog. Today, I think we're just going to stick with shrinking and stretching. I think that's all I have for y'all. What? It's not just that front number. It stretches and shrinks horizontally as well. Tell me what's going on now. But tell me in terms of waves. So tell me in terms of amp and period. Amplitude is 5. The period, is it? It's 4 pi, because remember it's 2 pi divided by b, or absolute value of b. So it's 4 pi. What does that mean for my graph? It's super wide now. It's taking twice as long to make a cycle. So now, absolute value of 1/2.
Throw that at me.
Let me just sketch up here so you see. Bless you. Yeah. Cosine, remember, starts at 1 instead of 0, right? And it goes down and up. All right, so this is my cosine graph. We know how to adjust the amplitude, right? Amplitude is where we just stretch it up and down, right? We could take this up to 5 and down to -5, no problem. That's the first thing we need to think about. But what we also need to think about in between there is my period is now 4 pi, as opposed to from 0, half 1. Instead of it taking that long to go up, down, up, and back up to the top, now it takes out to 4 pi to do that. So instead of there being a half a pi between each one of these points, I'm going to have a whole pi in between. Does that make sense? Here's the way I usually do it. I'll look at it and I'll say, okay, I have to look at the parent and think about it. If I can just pick up enough of the pattern to figure it out, I can get the rest of it. Because they're always equally spaced, up 0, down 0, up 0, down 0, right? That's the way they're always going to be. So I start shifting, but for right now. So if this is 4 pi, up top, my period is 2 pi, right? If I want to make my period 4 pi, that means there's a half 1, and a half 2, and a half 3, and a half. Here's 4 pi, right? Thank you. That 4 pi, so now this needs to come in between these two. So my black lines are now here instead of there. Does that make sense? One period. That's one period now. Okay, it's not the same thing. Here, this is every half a pi, right? This is pi. This is 3 pi over 2. This is 2 pi. So now I got two things going on. Remember, I'm going to take my highs up to 5, my lows down to -5. That's going to account for my amp. I'm still going to start here, but I'm going to go all the way up to 5, okay? Oh, dear. All the way up. Yep, 0, 5. All right, so I'm going to start. This is the way I reason through this. All right, we had f of x equals 5 cosine 1/2 x. 1, 2, 3, 4, 5. All the way up here. That's where the tops can be. And then the bottom is -5. Right, it goes down 5. So I've got 1, 2, 3, 4. Oh, well, don't do it yet. Don't do it yet, because I'm going to show you where it's going to be. Look at your period, your first period. What happens halfway in between the period? Because I'm going to start and end with a high point, right? Halfway in between, it's at my low, right? So halfway in between this period, that's where I'm going to put my low. That's what I was trying to say to you. 1, 2, 3, 4, 5. Right. Now halfway in between that, what happens halfway in between a high and a low? It goes to 0, right? So halfway in between this high and this low is 0, so that's going to happen right there. Again, halfway between, and now I've got enough to pick up this pattern. High 0, low 0, high, and then look at how many I'm skipping in between. I'm skipping 2, and this would be that 0, right? And then I would skip 2 again if I needed to, and that would be my low. And so I've got enough that I can pick up this. And all you need is one period. One period is enough to graph on it. Let's do another one. Bless you. Bless you. Because this is cosine, not sine. Cosine of 0 is... What? Why is it? Sine goes through 0, 0, but cosine goes through 0, 1. Oh, you could keep going. You could. I just only put one like that. Yeah. Each line's a half pi. Not in the mood, Logan.
Check him out. I was not ready for that.
What is your problem?
Because he is so aggravating.
Yeah, I'm gonna take you all 6 weeks.
Okay,
Check him out. Check him out. Check him out now. Yeah.
What did he say? I don't need to hear. I was recording it. Do I need to back up?
Yeah. Well, if you just listen to half of the sentence, then it's
All right. Yes.
Right?
I don't remember how to do that. I don't get what it is. No, it's just pi, Miguel.
2 pi over b. It's right. You do 2 pi over the absolute value of b, which gives you the period. That's absolute value of b. That's absolute value of b. Okay. We gotta do a couple of tangents. You can reflect them too. Can you reflect them too? Okay, so period is how long it takes. I always take the parent graph. So the parent of sine, right? The parent of sine has a period of 2 pi. Each one of these is a half of a pi. Well, I'm just doing the parent right now, show her. Sine and cosine, it's the same parent graph every time, but you just have to remember one starts at 1 and one starts at 0. So this is sine, the sine of 0, 0. So I'm just sketching out because it helps me. You may not have to do this every time. I have to sketch it out every time so that I look at it and know, what does my parent look like? Now from here, I'm doing 2 things to it. I'm changing the amplitude and I'm changing the period. The amplitude is easy because to change the amplitude, all I do is take these high points and I'm going to move them up to 4 and the low point down to 4. That handles my amplitude. But the period, changing the period is when it gets hard. Because changing the period changes how frequent it makes a cycle. So here, instead of going from 0 to 2 pi, this time I've got to be from 0 to pi. I've got to have a whole cycle done within this section. It's going to be real small. That's exactly right. So here's the way I do. I start. I always start at 0. Okay. Where am I at 0? The sine of 0 is 0. That's right. And I'm at 0. So before, okay, so if every one of these is a half a pi, right? So before, I got everything. I did a whole entire cycle by the time I hit 2 pi. But changing it to pi means I've got to squish everything in so that this whole cycle is happening in 1 pi instead of 2 pi. So I take my ends, right? If this starts at 0, then that's also where it's going to end at the period. So where does the period end? At pi, right? This is a half a pi. This is 1 pi. Right? It's really scrunched in. Halfway between, look at your parent graph, halfway between the two ends in your period, what's happening? Halfway between, it's another 0, right? It's another 0. Now, halfway between those two zeros, that's where my amplitude's happening. So halfway between these two zeros, I'm going up to 4. 1, 2, 3, 4. And I'm going down to 4. 1, 2, 3, 4. And that's what my graph is. One period's good. One period's good. I need to show you reflecting, and I also need to show you tangent. Still need to go to the bathroom? Yes, go.
He does his full name, and it's also the way he writes. But he doesn't do Connor, but it's just Wyatt Connor.
Oh, what?
Very right line. Wyatt Connor Thompson.
All right, this one also has a reflection in it, so your highs are now lows and your lows are now highs. Everything else is the same. This is also hard because your period is not going to be. All right, so I've got a reflection. The reflection. Oh, no, I didn't make them. All right, reflections. If that had any bearing on standards or anything else, then that whole conversation at lunch wouldn't have even happened. Because they're changing them with stuff next year. But there's a guy in charge that should be in charge. He doesn't know what he's talking about. No, making common assessments.
All the major assessments from now to I mean, no, this is you looking for.
Okay. Reflect. This one's going to be reflected, so your highs are going to become your lows are going to become your highs. What is your amplitude? Positive. We take the absolute value. So if I go through, which is 2.5, right? So I'm stretched out some, so I'm going up to 2.5, down to 2.5. How? What's your A? All right, period's harder. Yes. What? Slogan.
Last year, you had people sitting over there and laying on the tables back there. He can lay on the table.
No, because, no. Okay. 2 pi over b, sit up, Logan, sit up. Which is 2 pi times 3 over 2, which is gross. All right, again, you don't know how I got there? All right, so it's 2 pi over b, and b is 2/3. So 2 pi over 2/3, and instead of dividing by a fraction, I multiplied by the split. All right, if this is cosine, we'll do that next.
Tomorrow. She left.
No, we're not doing it tomorrow. Cosine of 0 is 1. All right, I'm just sketching out the parent here so that we can get a feel of the period and what's going on. All right. I just needed one period. All right, parent, right? Now remember though, my highs, because I'm reflecting, my highs are my lows now and my lows are my highs now. So it's going to start at -2.5. 2.5.
What do you do with the 3 times?
Oh,
All right, so this reflects it. And my highs become my lows and my lows become my highs. So if I started at a high on the parent, then a reflected one starts me at the low on the transformer. The negative in front. Your amplitude is 2.5.
It's going to be like really wide wavelength, like 3 times.
Okay, right. So I get to stretch out a little bit further, right? There's a half, there's 1, there's a half, there's 2, there's a half, there's 3. So again, if I start at my low, I end at my low. You're not on pies on your y-axis. You're just counting by 1. Yes, this is 3 pi. So this is a half a pi. This is pi. 1.5 pies. 2 pies. 2.5 pies. 3 pies. Stop. Logan. All right, halfway in between my 2 highs, which are now my 2 lows, what happens on the graph? I'm going to be at a high, right? Because halfway in between, I'm at a low. My low now becomes my high. So halfway in between these two, I've got a high. What is halfway in between? 1.5. Right. 2.5. That's exactly right. And now halfway between the high and the low, my 0 happens, right? So halfway between, I've got 1, 2, 3, so I need to go 1.5 over. That's how I judge it. Yes.
Why can't you just like do it like that?
That's the way I do them. That's very true. Halfway in between, from 3 pi over 2 to 0, that's 1, 2, 3 units or 3 dashes, so 0. Zeros happen when y is 0, so it'd be where cosine equals 0. Yeah, right here. And then in the middle of these as well, 1.5. Halfway between, I don't know. What is 2 pi plus 5 pi over 2? And then divide it by 2. 9 pi over 2. It'd be 9 pi over 4. He asked what value that was. That value is actually, you don't have to know that. You can just graph it, but yes, it's 9 pi over 4. You'll have to put it on here, but I am letting you just look at the middle between the two and graph it where it needs to go. But I want it graphed on there, but for one to get hard like this, you can just put it halfway in between. You need to make sure you have at least one complete period. No. All right. Your calculator will graph these as well, and you can look at them, but it's hard to tell what's what on there, so just make sure you've done it right. All right, let me do a tangent real quick.
Justin wanted to go.
Get out of here.
Which part? Graphing all together or this one? So what I did was I looked at this and I said, okay, between the two high points lies a low point, right? So between you want some graph paper?
No, there's all of these.
Here, if you want some graph paper, grab one and pass it down.
Yeah. Good luck, Logan.
It's printed on there.
I gotta share. No, he loves why. Why was like he walked through the hallway? I was like, in the hallway. He's going to lie. He's going to like go away.
Yeah. And it's reflected, so the highs become the lows and the lows become the highs. And then your period, let's see, 2 pi. I'm going to go ahead and flip
Why
it.
did that one time it started to load? And now it's
I got 3 pi over 4 for my period. So this one's going to be gross. Yeah, it's just reduced. If I'm doing this one, I'm probably
no. Hey, no, please. No. No. It is. Yeah, it's got a little.
All right, here's what I would do to help me with this one. Because my period is over 4, that's halfway in between 1.5, right? In between 0.5. So what I would do on my graph is I'd probably label them by 4s. So 1, 2, 3, there's a whole pi. This is pi over 2. You're basically putting an extra tick mark in between each tick mark to help you. You can label them however you want. So this is 1/4 of a pi, this is 3/4 pi, so on. So that's how short it's going to be. I just wanted you to see what's going on here and how I would do this. So I'm still, remember, highs become lows, lows become highs, but my amplitude has not changed. So I'm still starting at 0 and I'm still ending at 0 at the end of my period. And now I need to go halfway in between this so that I find my other 0, right? So 1, 2, 3, so I need to go over 1.5. And here's where it's going to get gross. The height, that's this one. Okay, yes, but it flips over. So in between these first two, that's going to be my low, right? That's this one, and this one. That's where I am. It does. And then halfway in between that is this one. And that's what I put right here. Yeah. I got to do the whole. Okay, so yes. So what's in between? Well, I need to go over, I've got 1.5, so half of that would be what, 3/4? So over 3/4, and that's going to be my low now. And then 3/4 this way, and that's going to be my high. And so this graph looks like this. Dozer, what sheet do you have that you're writing on right now? Let me see that. What's the start with? That's the wrong one, buddy. I was wondering where my example sheet went. All right. Tangent's actually a lot easier.
That's definitely the homework.
I'm almost done. What's not making sense? You put the same points like the mine are? You put the. I told y'all, everybody struggles with this for some reason. It is hard.
Why are you in the...
Y'all are really squirreling on me right now. It's okay. It's all of you. All right.
I have to every time. I ain't touching up the airport.
Are we actually trying on it?
I'm not passionate.
I can't go.
I saw y'all look yesterday. You're right, y'all not passionate.
Dude, I knew what I was talking about.
Tell me what you know.
It's tangent 3, amplitude.
Oh, it's tangent. No amplitude. There's no amplitude. It is stretched out, but there's no amplitude. Noah. The 3 is irrelevant for us right now. I'm not gonna make you do a whole lot with it. But what you are your period. That's what's gonna make the biggest difference. So my period is pi divided by 2/3, which is, now remember the parent. The parent was the tangent of 0. And then tangent of pi over 2 is undefined, right? All right, this is my parent graph for tangent, yes? So now if I make the period be 3 pi over 2, oh my gosh, I don't need a microphone.
The mic.
Look, here's why this is confusing. Here's why this gets confusing. Even though the period is pi, the period is straddling the the y-axis. So you've only got a half a period on either side. That's going to be the hard part of this. Okay, so because look, this is pi over 2. This is negative pi over 2, right? The period happens. This is together makes pi, right? So what I have to do is I have to take this period and I have to straddle it over the y-axis. So I only need half of 3 pi over 2 on the right side and half of 3 pi over 2 on the second side, left side. Right. So what's half of 3 pi over 2? I'm ready to go home. If you're watching this recording, this is as painful as it sounds. Everyone says hi, Addie.
Same thing as you.
And Lee. We miss you too, Lee. Okay. You never watched the
You
video.
were. No, you were. You were offered extra credit, Logan. Yeah. You know, this would be a picture of a frog. No, you didn't.
You must not have wanted your extra credit then. Okay. So remember, fours, if I go by fours, that's halfway in between here. So I can kind of think about it like this. So 3 pi over 4. 1, 2, 3. Here's my new asymptote. Okay. These are hard. So we're going over essentially 1.5. All right, because if my normal units go for half pies, but I need them to go by quarter pies, a quarter pi is a half of a half. Right. And I go 3 of those. 1, 2, 3. Because I need 3 pi over 4 on either side. Yes. The asymptote's on pi over 2. 3 pi over 4. That is halfway between pi over 2 and pi. Yes. And then what I'm going to do is I'm just going to make sure this looks like, I'm not going to make y'all find another point because this is hard enough as it is. It's a vertical stretch, so I'm going to make sure that I really kind of stretch it out some, but it's going to hug the asymptotes on either side. And that's it. Please know that it keeps repeating this and it goes on forever and ever and ever, but I'm not going to make you do but one period.